Yeah, I'll be presenting a project that we've been working on with several different experts in the biostasis field, including Emil Kendziora. This is one of the sub-roadmaps of the LBF roadmap on biostasis. The team leads here are Andy McKenzie from Apex Neuroscience, Emil, who you heard from earlier, and myself. But we also had a lot of great contribution and couldn't have done this without Brian Woke from 21st Century Medicine, Anton Arkhipov from the Allen Institute, and Boris Rogel from EIBR. Okay, we already asked this question. Who here has signed up for Chronics? Very few people raised their hand, despite a lot of people being interested in this, and despite the fact that I think more than 80%, 90% of people here said that they don't want to die. Another question is, who here actually wants to work on cryopreservation or biostasis? Raise your hand. Okay, also, very few people working on this. Why? I'm going to give you 10 seconds to think about it, and then turn to your neighbor and tell your neighbor why you think nobody's working on cryopreservation. I'll give you 10 seconds. Okay, turn to your neighbor and tell them why you don't think they're working on cryopreservation. Pencils down, pens down. Okay, class reconvene. So what was the answer? Someone shut out. Like what? Hubris. Okay. Other approaches are more exciting. Yeah, potentially more sexy than getting vitrified. Okay, fine, fair enough. Okay. Already people. Okay, I'm going to dismiss that notion in a second. But okay. So you already saw this in the beginning today when Mark presented the roadmap. We have three different, paths, and originally, originally replacement was number one, but then we then switched it so that biostasis was number one, stack ranked in terms of priority, and I will explain why, Omri, in a second. But the general motivation for just doing this roadmap in the beginning was because, at LBF, we have a lot of newcomers coming to the space. They are people, technologists, scientists, engineers who, they don't want to die. They believe life is good, and they want to know what they should work on. So we started this roadmap as a way to give people a snapshot of the field of the different ways they could get involved. So that's on the talent side, right? But then there's also the funder side. So if funders come to the space and they have no idea what's going on, they just see a collection of uncorrelated research areas, then it's not very compelling to for them if they can't see some sort of sequential narrative or some sort of actually connective landscape for how this is all going to work. So that was kind of the motivation here. So we're going to go a little bit deeper into the biostasis roadmap. Okay, so why biostasis is our number one priority on the roadmap? Well, first of all, people are dying today. I think this is an underappreciated point, maybe. When we first started the LBF roadmap, we asked ourselves, who is this roadmap for? And there's this hidden, assumption that it's for, fairly youngish people who are have many, decades in their career to put towards this thing. But the sad reality is people are dying today, and there needs to be some sort of solution for them if they also do not want to die, right? So that's really important. And then number two, even if we solve aging, people die of biomedical conditions that are not related to aging at all. So this is still going to be a problem that needs to be addressed. So we need something to put biology on pause until some other solution can come along. And then number three, which Emil alluded to earlier, which is basically, the timelines for rejuvenation technologies are uncertain. Are you so confident that you're willing to risk eternal oblivion, I guess, that this is going to all work out within your lifetime, that you think that we shouldn't work on biostasis, or that you shouldn't be signed up for some sort of, let's say, fallback plan against entropy? You should really think about that. So so that's why we decided to put biostasis as the number one priority in the LBF roadmap. And now I'm going to talk a little bit about the roadmap project that we started. Sebastian already alluded to some of these. So there are other examples of biostasis or preservation roadmaps. The OPA Roadmap Organ Preservation Alliance, obviously, 2015. And of course, Cradle Health has like a kind of like one-page white paper on their website, kind of detailing their roadmap for reversible cryopreservation. And then something that might also be relevant is the Anders Sandberg, the whole brain emulation roadmap back in 2008. But but our roadmap is focused on preservation of the brain. And I'll explain a little bit more in a second. I think Sebastian also kind of described some of the motivation for why you might want to do that as well. So this is our roadmap visualization. If you go to our website over here, you can interact with it. There's clickable sort of elements that you can learn more about these different areas on the roadmap. So I'll give you a little second. And this is still actually very much a work in progress. This is kind of like V1. We're going to continue improving it annually and continuously. But so the visualization is on the website, but we also have a white paper that we submitted, which you can also read. There's a link on the website as well. Okay, so overview of the biostasis roadmap. So for the biostasis roadmap, we wanted to focus explicitly on structural neural preservation. So neural part, I think most of you sort of understand why. The brain is the seat of personality, identity, memories. So it is very much a necessary part of what we need to preserve if we want to not die and preserve the important parts of our consciousness and so forth. And then structural, we're really focused on preserving the informational parts of the brain, and I'll talk about that a little bit more in a moment. But so then the second part was in terms of like the vision for the roadmap was an idea of kind of having this like detailed to-do list of all the different research milestones and goals that might be interesting or useful to develop, biostasis, neural biostasis, essentially. And in detailing those research goals, we also wanted to attempt to estimate the resourcing requirements to address these, or at least to significantly, I guess, de-risk or investigate these different research goals. And then also attach the different organizations that are working on those research goals as well. And as I said before, we collaborated with many experts. First, it was just through interviews with many different experts, but then also enlisting collaboration with some of the really great people I mentioned earlier. Okay, so high-level objective of the roadmap for the technology is first and foremost, we do like as a really at a really high level. We want to get to provably a reversible preservation or a suspended animation. But the issue here is that the timelines are somewhat uncertain here. People are dying today. So this is kind of like a medium to long-term focus of the roadmap. But there's a ton of things that could be done today. So number two, in terms of improving the fidelity of the structural preservation of the brain, okay? And so this is kind of like the more immediate focus of the roadmap. Okay, so after talking to a bunch of different experts, we created a list of to-dos and categorized them in these 7 different categories. So just briefly, we're looking at pre-cardiac arrest, post-cardiac arrest stabilization, preservation compounds, procedures, quality metrics, long-term preservation, and restoration recovery. And then within each of those categories, we kind of break it down into the 2 sort of major modalities or paradigms used for preservation. So those are cryopreservation and also chemical fixation. And just roughly like the relative sort of like trade-offs between the 2. So cryopreservation is like the aim there is to really preserve the native biological state of the tissue or your brain, etc. Which is great, but the downside is you have to do this difficult fast cooling or fast rewarming, there's difficulty in the procedure, let's say, to get good preservation. Whereas the other main modality, chemical fixation, you get great structural or morphological preservation. But then the downside, the trade-off there is it's potentially very difficult to reverse that preservation because of the chemical crosslinks that are formed in the what they use is like an aldehyde stabilization. And then, of course, there are also things that are sort of general that are applied to both. So different research goals that are relevant to both paradigms. Okay, so now I'm going to hand it off to Emil, who's going to also chime in and go into some of the details of the roadmap.
Sure, I mean, it's mostly up for questions, I think, because I think the high level, if we go through all of those details, it's gonna, we're gonna be way over time. I'm not sure how much time we have anyway.
Not much.
Not much, all right. So then I think we mostly go for questions. So the idea is basically for all of these categories that Nathan mentioned, go into detail, like, for example, precardiac factors would be, anticoagulation, monitoring, and then basically do that for every part of the main topics that the roadmap includes. Ideally, to bring people in and give them an idea what they're working on, if they want to work in that field, how that fits into the overall narrative, and then B, give funders an idea as well of how their money contributes to making this work in the long run. Stabilization, of course, is one of the most important factors, basically initially in cryopreservation, making sure that there's no further ischemic damage to the body, so fast cooling down, cardiopulmonary support, medication, and all of that, which all either needs to be optimized, new modalities be found, and so on. Then going on to compounds, which is mostly cryoprotective agents, less toxicity, better glass formers, and so on and so on. Long list of things that need to be improved here. And then in the interest of time, I don't know if we can discuss all of these in detail, but this is just what I said, right? Lower toxicity would be an important point. Finding cryoprotective agents that only need lower cooling rates, and so on and so on. Same for chemical fixatives and for things that are required for both. For example, blood-brain barrier modification to get the cryoprotective agents through the blood-brain barrier. Right, procedures. Mostly surgical, some cooling methodologies, some perfusion methodologies. Basically, how do you get these cryoprotective agents into the body and where they need to be? Then monitoring, very, very important. Cryopreservation currently has a couple okay quality metrics. There's a large range of additional quality metrics needed to actually understand how well is something preserved. Mostly it's currently being done by CT scan. That's why we have a CT scan in our facility, as you saw before. The next step will be probably better metrics for ultrastructure preservation on electron microscopy. I just said that ultrastructure preservation would be one big thing. And then last but not least, even though this is not yet possible, would be also viability after preservation. Long-term storage, it's probably the smallest problem, not that much to be done. Slightly different temperatures in storage can improve long-term storage quality a bit, but this is mostly to have a complete list. There's not that much that needs to be improved here. And last but not least, of course, the very big topic would be, okay, how you actually bring someone back from cryostasis. That's why all the dollar signs are like very, very expensive here, because there's a lot of fundamental work needed here. And in the interest of time, I don't know if there's any questions or if you want to close. With next steps.
Yeah, next steps. So just quickly, here's the Biostasis roadmap. So we want to update this annually to reflect different, advances in the field and so forth, and also continue to attach organizations that are springing up and working on different areas of the roadmap. And then, another thing that popped up. Did you want to talk about the survey?
Oh yeah, one of the next things that we're doing, we're preparing a survey that will be sent to all neuroscientists that work in the engram preservation field, so memory preservation field, to gain an understanding of what does the neuroscience community believe would need to be preserved So like what physical property, like structure or cell membrane configuration and so on, to then potentially be revived in the future. We're doing this together with Andy as well, and with Ariel, who's a neuroscientist from Australia.
Yeah, and another thing, we barely scratched the surface on cost estimates. I think a lot more work needs to be done here to make things more concrete and tangible for potential funders in the future. But yeah, so this is just what we're working on. And if you're interested in getting involved, one, yeah, give us feedback. If you disagree with any of this stuff, let us know. And then number two, yeah, if you want to collaborate on future versions of the Biostasis roadmap, just get in touch. And then last, yeah, work on Biostasis. We're going to potentially need it. Well, you definitely need it as a backup plan. So, yeah.
Strongly agree. Thank you, guys. And I think it's really important for this thing to be a living document because, of course, I mean, when you guys built the original roadmap, like you consulted a lot of people, and this science evolves, and so this is going to be a living document. It's going to grow. It's going to get input from as many people as we can with all the expertise that we can. We don't have much time. I'm gonna ask one question myself, which is, where does cryobiology fit into the category system that you guys had?
Yeah, it was under cryoprotectants. I think we had it under compounds. There was there we go. Where?
Okay. Any other questions?
I mean, I would say it's a little bit everywhere, right? It's also the restoration with the rewarming. It's, you know, a lot of the post-cardiac arrest stabilization things and so on too.
Yeah. Questions? All right, we're gonna start the last.